So the testing we did to validate it was we did two types of tests. One test was we did a top-down static test. Then we came back and we did a torsion test on the object. So now the torsion test was very unique. In Florida, no one's ever done a torsion test in the field to failure, okay? And so what we had to do there was we had to build similar load scenarios we expected out in the field. And we had to do that also on a drilled shaft to compare the results to, because we want to have the same soil conditions and we want to have the same loads and compare the results from both types of tests. We ran two tests. We had two jet grouted piles. There we went up to a total of 14 kips, and then we were worried about the capacity of the mast arm, and so we stopped there. And so that one, definitely, we were up to about 3 times the capacity of the drilled shaft. In this test, we were able to successfully go up to 1,200 kips of static load, and we had about 2.5 inches of movement. So we reached the ultimate capacity of this foundation, and it was over in the neighborhood of 1,200 kips, which is in the neighborhood of 4 to 5 times the capacity of a drilled shaft for that same length object. For a drilled shaft, in the same soil conditions, we would have to have a drilled shaft in the neighborhood of 45 to 50 feet long. It's almost twice the length of the jet grouted. It's over twice the length of the jet grouted pile in that process. And we got a total static resistance up to 2,500 kips, which is 1,250 tons, and we only had a movement of that object of 1.5 inches. So that means it still didn't fail, okay? Even at that type of load, we only got 1.5. The failure load is about 2 inches on this object, 2 to 2.25 inches, and we were only getting 1.5 inches of movement, and we had 2,500 kips on that object. And then we looked at the distribution of load in that object, and the distribution of skin friction in that object was about 3 times what we saw on the regular drilled shaft in terms of the mobilized skin friction on that bottom. And we also saw an increase of end bearing on that object of about a factor of 2. Again, we didn't fail the object, so I'm sure there's more there to give if we want to carry it out to further deformations in that process. So we feel confident that this can be brought into the field and in practice for the shortened lengths of drilled shafts, both under bridges and other buildings and whatever. And we feel that the cost-wise, this thing will save maybe somewhere between 20 to 50% the cost of a typical deep foundation in that process.